Hey everybody, welcome to Design 30. This is another tutorial, and in this tutorial I'm going to show you how to design, quote, and order a custom sheet metal bracket. Before we get into that, if you're enjoying this channel, please like this video and subscribe. Okay, so we're going to be in Fusion 360 once again, and you're going to want to be in this sheet metal tab right here. First thing is create a new component, and you want to make sure that the type is sheet metal. And you can rename the component right here. We're just going to call this a bracket, since that is what we're going for. And then there's a sheet metal rule here. This is what you're going to use to select your material, as well as the thickness of the material and a few other parameters that I will show you how to set up in just a few minutes. We're going to stick with steel for now. Okay. So we have that selected. We have a bracket, which is a sheet metal part right here. And so what we want to do first is create a sketch for the base flange. So this is if your bracket is going to, if you were to flatten it out, what would it look like? And so this could be for any sort of project. Maybe you're trying to hang stuff on the wall in your garage. Maybe you're trying to attach two 2x4s, whatever random project you're working on. You might need a bracket with some sizes that maybe you can't find it online. Maybe you can't find it on McMaster and you need a custom part. Well, there's a pretty easy way to do that, and there's a pretty good website you can use to buy it, which we will get to in a second. But let's get into this sketch. Okay, so we've got that started. We'll click here. All right, what shape do we want this to be? Let's start with a rectangle. Start it here at the center. And we're gonna want this to be, let's make it about 3 inches tall. And width-wise, let's do 1.75. Okay, so this is our base. That's good enough for now. We wanna go to create and create our flange. Click on this profile here and hit OK. And there we go. We've got this profile, this part already made. And if you look at what the material is, or the rule you can see right here is the steel, kind of generic part or generic material with some generic properties. We want to make sure that's something that is actually manufacturable and properly set up with the correct properties. And also made out of the material that we want. So the first thing to do is figure out where do you want to buy this from? And my recommendation is a company called SendCutSend. Okay, so this is a website where you can do laser cut materials. I often do a lot of laser cut metals, but there's a lot of other things here. You can see there's a whole list of different materials that you can order to be laser cut. And if you want it to be a metal, then you can also do some bending. You can do PEM inserts, you can do threaded holes, all sorts of different things. But for this bracket, we want it to be metal. So let's look through here, and here we go. Here's a G90 galvanized steel. It says it's great for outdoors and marine applications. Well, I'm not thinking marine applications, but definitely outdoors. We want something that's not going to rust. Sounds like a good idea. Okay. It gives you some different specs on this. Gives you the tolerances, what the typical lead time is for shipping. Starting price of $29, which is incredibly cheap for prototype parts or even non-prototype parts. It's a really good price. Tells you what it can be used for, gives you some strength and corrosion resistance ratings. Keep scrolling down, gives you some ideas of what you can make out of it. But we're not really interested in all that. The first thing we want to see is, okay, what are the different thicknesses? What gauges of sheet metal do they have available for us? So anywhere from 30 thou all the way up to 74. Let's go with 74. We want this to be a hefty bracket. Okay, keep scrolling down. Tells you that it's 14 gauge. It gives you the thickness tolerance on the positive, thickness tolerance negative. That is important to be aware of depending on what you're designing. But what we're really looking for as far as Fusion 360 goes is some of these specs down here. We want to know the K factor, very important for how this thing will bend. We want to know the effective bend radius at 90 degrees, 0.063. And once you have those, there's a few other things in here that might be useful depending on what you're designing, but that's a good place to start. So let's flip over back to Fusion 360. We want to go up here to sheet metal rules, and you're going to go to your library. Actually, you can go from the library or what's already being used in the design. Doesn't really matter. Let's say we have a few other random ones here. Let's just take this and create a copy of it by clicking that button. I use SCS to stand for SendCutSend. That way I know I've set this up per the recommendations of what SendCutSend is capable of and what they recommend. We don't want A36 steel though, so let's go and make sure this is appropriately named. That was G90. Make sure we have the name correct. Let's see here, scroll all the way up to the top, laser cut G90 steel. Okay, that's what we want. Make sure that is named properly, G90 steel. The thickness we chose was 074. Let's make sure we are double checking that. 074 is correct. Okay, we'll go back down to some of these properties. And you go back and forth a little bit here. That is the thickness. So make sure you update the thickness to 074. K factor was 0.4. And then there's also some bend conditions here. Bend radius 0.063. Let's double check and make sure that's correct. I believe it was 063 at 90. That is correct. One more. Bend relief depth 0.157. Let's go ahead and update that here as well. Here's our bend relief depth. And what was that? 157? Let's double check that real quick. 157 is correct. Okay, that's good enough for now. Let's bring this up to where we can save it. And now we have a new sheet metal rule. It doesn't actually set the material itself, but what it does is define how this part, this bracket, this body that we've made, what the thickness is going to be and how it is going to bend. So let's close that, go over here, click what we just created, G90, okay, hit okay, and this should automatically update, but we can double check it just to make sure everything is working properly. 0.074 is correct. If you want to update the actual material, go to modify, scroll down here to the physical material, and takes a little while to load. Let me make sure my face is hidden here. And let's see what we have. Go to metal. Let's see if they have some galvanized steel in this library of materials. Here's our stainless steels. Here's some other steels. And depending on what you're doing, if you're trying to get some very accurate weights, things like that, make sure you're selecting the right one. Here we have a galvanized steel, that'll work. Drag and drop it over, and it even has that look of galvanized steel, which is pretty useful. Okay. So we're off to a good start. We have our material set. We have our sheet metal rules set up per SendCutSend, the website we're going to use to buy this, per their recommendations. Now let's finish designing this bracket. So I want to add some slots. So let's create a sketch. There we go. I'm going to do a line. Let's see. Let's make a center line vertically and a center line horizontally. There we go. Let's create some slots on this. Zoom in just a touch. Okay. Oh, we don't want that to be construction, so we'll pull that over here. All right. Okay. Let's see. Let's make it about 0.75 inches long. And I think we want to use 1/4 screws. So that thread is going to be about 1/4 inch wide. We want it to be a decent, pretty loose fit. So let's make this about oh, I don't know, 0.27. Give it about 20 thou gap, 10 thou on each side of the threads. Well, let's go a little bit larger than that, actually. Let's go 0.275. That should be good. Okay, and let's make sure to finish dimensioning this to make sure it is fully defined. 0.4. Let's move that out a little bit more. Let's go 0.5. Perfect. Okay. And now one more dimension. Pull this off here, go 0.35. Now that is fully defined. And to speed things up, we're just gonna mirror this. Go there, select this mirror line. Okay. Do one more mirror. Let's select both of these. Select the mirror line. There it is. Okay. Now I'm going to hit E for extrude. I'm going to click each one of these profiles. And then I am going to do a cut extrusion through all. Click that. And okay. So we've got a bracket here with some slots. And before we actually put the bend in, I want to put a radius or a fillet on these corners. No sense in having sharp corners on this thing. And okay. 0.13, that's good enough. Okay, now we need to bend this. Let's see what it's going to look like to be bent. We want to bend right in the middle. Let's create one more sketch for this bend line. Make sure you click your line tool. Let's put it right through the center here. Okay. Finish that sketch. Go to create, click bend. And okay, so now we need to start by selecting a stationary side. Click that side, and then the next side is the side we want to be bent up. And there we go. You can also change the angle of your bend right here. You can change the direction, flip it either way, and where the bend actually starts. I'm going to make it a center bend. So the center of that is located at the center of the bracket where we place that bend line. Okay, so that is essentially the end of this bracket that we just designed. Pretty quick, pretty easy. But let's see, how are we actually going to get this made? The design is done. Now we need to essentially get a quote. How much is this thing going to cost? And then we can get to the point of ordering it. So there's one more step we need to do before moving on to that. And this is going to allow us to create the file that the website SendCutSend is going to want from us. So we're going to go to create a flat pattern. Again, click a stationary face, hit OK, and it creates a flat pattern. So essentially just gets rid of that bend and flattens out this part. You can see in the center, it has our bend lines already built in or shown overlaying on this part. Okay, but now what we need to actually export is the DXF, which is essentially a one-to-one drawing of what this part looks like, so they can program their laser to cut it out. And then it's also going to have the bend lines, which the website will use to understand how you want your part bent. And you'll see that once we start going through the website. So let's click on the DXF, hit OK. It's going to want a name. Let's call it a bracket and underscore 0.074 inches underscore G90. That's good enough for now. Where do we want to save this? Desktop design 30 tutorial files looks good. And boom, that is saved. Okay, let's switch back over to SendCutSend. I'm going to pull up my face here. Hey, everybody. So how do we actually get this thing uploaded and start configuring it in their configuration tool? So you're going to need to create an account. I have one created already. It's really quick and easy. You just need an email. Then you're going to go to browse for files. And I saved it in this folder. There's our DXF file. Hit OK. Take a little while to upload it. And there it is. That is essentially the flat pattern of our bracket that we designed. But we want to configure this thing. So let's see here. Part builder. Oh, that is not the right thing to click on. Click here. And what am I looking for? Let's try this one more time. Upload, click on this, open. There we go. That's what we're looking for. It often goes straight to it like this. I'm not sure why it didn't do it the first time. But here you can select what your units are. We designed this in inches, so we want to make sure that is still selected as inches. Hit confirm, and let's find our G90 Steel. That is going to be under this. There it is. It's a new material. And we wanted 074. Gives you the rough price for just cutting this out of the material itself. Some of those prices are covered up by my face. You can see at quantity 2, it's only $4.17 each. Pretty inexpensive. Again, the minimum order price is $29, so just keep that in mind. That is the least you're going to be able to pay for something. But that just means you can order more quantities and get 4, 5, or 6 of these. But once we add some bends, this price is going to go up just slightly. So here you have a 3D view of your part. Makes it really easy to make sure that it's uploaded properly and it's the part you expect. Here is where you add your bend. So this is going to tell us that there's a chance for warping. It's a nice little warning. Since our bend is close to the slot, there might be a little bit of distortion like this. We're not really concerned about that for this part. So just say that you understand, ignore all the warnings on this part, and let's keep moving forward. Here we want to go to 90 degrees. That's how we design this part. You can zoom out a little bit here, and that looks pretty good. Okay, done. And you can see that price went up a little bit. Cost for 2 is now $7.16 each. So just a couple dollars, not a big deal. If you have a larger part, they will often give you more options. Sometimes you can get it deburred or tumbled. You can do, for some things, you can do powder coating, hardware insertion. There's a lot of different options depending on the size of your part. And they have recommendations. They have, when you look at your part and the material thickness, they'll tell you the different options that you have for finishing it and post-processing. But for now, we just want this bare part. That's why we went with a galvanized steel. Don't really have to worry about powder coating it. So let's hit next. So here's some of the finish options. We could powder coat this. Let's not do that for now. Let's click no finish and hit add to cart. And then let's view that cart. Okay, so here you can see it's $9 for just quantity 1. Let me hide my face real quick here. You can see that there's some adjustment fees. And basically this is just to bring you up to that $29, which they said is their minimum price. Makes sense, but it really is a good deal, if you're buying one. But you might as well just bump this up until you hit that minimum price. So there you can see at quantity 2, it's still $29. If you go to the quantity 3, it's only $31. So it's probably worth 3. If you bump it up to 4, it's only $34. So, you might want to buy 4 of these and have a few extras just in case it turns out for your project that you need a couple more. And at that point, then you just put in your shipping information, make your payment. And the estimated ship date is June 10th on this. So that is pretty soon. Today is the 5th. So that means 5 days. These things are going to be headed your way with a few days shipping. You can get parts in 2 weeks, sometimes less. So really, really impressive, really, really useful, and a great way to get parts quickly, get them prototyped. And maybe these are parts that you actually want to put on something you're selling. I've done quite a few parts through SendCutSend now, and they've always come in with really good quality. One thing I want to note is that I have no affiliation with SendCutSend. I'm just a customer of theirs that has been really satisfied. So there it is. That's how you design, quote, and then order, if you want to, a custom sheet metal bracket. Really quick, really easy. again, SendCutSend is a great way to go for getting these sheet metal parts. That's it for this tutorial. Thank you so much for watching. Again, if you're finding these useful and helpful, please like it, subscribe to the channel, and share it with your friends. That would be a really good way to help me out. If you have any other questions, please put those in the comments. And if not, you can make sure you're subscribed so you get any new videos and you get alerts of all the new videos. Yeah. Thanks again. As always, remember, design more, despair less. Thanks for watching.